Okay. So what I'm going to do is just on a spot basis, we're going to work some of these problems, but like I said, they're pretty representative of the types of problems I noticed almost really virtually everybody had trouble with on the test. So we're going to just take that little extra time to go through some of these. It's also kind of foreshadowing a chapter that's coming up that I noticed that a lot of people had trouble with last year, and it had to do with them not really fully understanding this as well as I would have liked them to. So these are AG Math handouts, of course. And I've started you guys on page 6. So page 9 should be fairly routine, but let's just go ahead and start working through these. These only went up through 6.3. You'll have to remember all the circle properties that we talked about when we left off in order to be able to do these. If it's not jumping out at you how to do it, I don't want you to spin your wheels for a long time. Raise your hand and say, I just don't remember how am I supposed to be able to do this, and we'll go from there, okay? I think that first one on the page might have been one that a lot of you had trouble with on the test. Does anybody remember how to do that one? You do?
Yeah.
Okay.
Just figure out all the angles. And since VW is a diameter, that means that UV is 60, and then the last one, VY, would be 80. And since you know the two arcs of the bow tie, I guess,
Yeah.
you would take the average, because both the
Exactly.
angles have to be the same.
So what is arc UV?
60?
I get 50. Did I do my math wrong?
You have 130.
Huh?
Oh,
Right?
you're right, yeah.
This, isn't it 180 minus 130?
Yeah.
Yes, okay. So once you get that, right, okay, then how do I know what x and what x is there?
70, right?
Yes. We just started right on this one. These are the kinds of problems that everybody missed, quite a few of them on the test. So that's why we're working on it. Okay? Okay, so did that seem completely mysterious to anybody? No? Or did you follow it? Okay, so if I've got an arc over here that's 50, right? Okay? And I've got another one over here that is 70, right? Everybody see how I got that? Is that right?
90.
Do I have my numbers? 90, thank you. Okay, if this is a diameter, right? If this is a diameter, this also has to be 90, this has to be 130, right? Okay, so what I'm looking for are these vertical angles. And because the vertical angles have to be equal, they're just the average of these two. So 140 divided by 2 means they are going to be 70 degrees each. And I think a lot of you were not sure. I know I showed you how to do it, but we didn't practice it a lot, so that's why it's going to be coming up. Make sure you know how to do one of these, okay? Everything okay? Ready?
Yeah.
Okay. Okay. Okay, so that's number 9. So that's what you had to know to solve number 9, okay? What about number 10? What do we have to know there? It's the same, it's actually the same logic for number 10. What is the sum of the vertical angles?
180.
180, right. So what does x have to be? Ever see that? make sure you know how to do these. I'm going to have you do some of these at home, okay? But I did want, like I said, how about we look at, let's see here, 11. Yeah, why not? There's more than one way to get to this one. I would, there's more than one way to do it. What might be the easiest way is to extend one of those into a diameter, and then it becomes, I think, a lot more clear. When I do my keys, I actually have a little straight edge, and I'm almost always adding lines and things to it to help me see what's going on there. Does anybody think they have an answer? Right? What does that tell me?
Wait, how'd you get 52?
Inscribed angles, right? So this is one, that's 52, that's another. That's the key, right there. Says this is a diameter, what is that? What is it? Says this is a diameter, this has to be,
38.
huh?
38. Oh, no, wait.
This arc here, isn't it 180 minus
Yeah.
104, 76, right? Okay. And of course, these are, it's going to have symmetry because these are all the same, right? So, am I being asked for what the remaining arc is? Yeah. What is it? It's just,
104.
it's 104. Now it's just. Does this make your brain hurt after the week, the break, or is it coming back? It's just arithmetic, right? When you know a
Seems
couple
a lot
of.
easier after the break. Like I
Does
didn't
it?
have a clue how to do it before. Now it's just like, oh.
Well, by the end of this week, I think they're going to really be, because it's what we're going to work on all week. And because this is such a foundation to trig, and if you're going to take trigonometry in another year or so, might as well get it down. And I looked at your syllabus. You guys have the time to do it. I'd like to get it down. So anyway, that makes sense. Yes? No? Okay. Make sure you know how to do that. 12. What's the key to 12? What is a property? What is that thing called in the middle of that?
Cyclic parallelogram.
Cyclic. Well, it's not parallel. It's a
Oh.
quadrilateral. But yes, I understand what I understood what you meant. Those aren't parallel, but cyclic quadrilateral, which mean what do we know about that?
That its opposite sides are supplementary.
Or it's opposite
And
angles. angle. Yes, we're all misspeaking today. That's perfectly fine. But at least I understand what you're saying. Yes, the opposite sides are supplementary. So how can you see how we would get x from that? What would angle F be?
95.
Right, so what would major arc EDG be? So what would arc DE be?
70.
Correct. You did that right. You were getting there. You were getting there.
I think so, yeah.
I'm pretty sure. You had already said some of the logic. Okay, 13 and 14 are a little bit of a challenge. I will put up the answer key to that, or I might go back to that. I've got a lot more in this packet that I want to go through. Let's skip over to the next page, okay? 6.4, they were introducing you to the idea of doing circle proofs. And again, I'm not into right now doing the formal proofs. In fact, at the top when it says prove each using a 2-column proof, you can cross that out and just put paragraph. What I really want you to do is note the logic. I just want to just talk about the logic. Because some of these, that's really all you need to do. Take a look at number 1. What I want you to do is just take a moment looking at that. I want somebody, I'm going to see if I can get somebody to be willing to talk to me. How? What would you rely on? How would you prove that those two arcs were equal, were congruent? Let me ask you a question. What would you want? What would be one way to know that they were congruent? If I knew this, then that would tell me. What would that be? Everybody's super quiet. You guys are more quiet than usual.
Is it because the lines are parallel?
The lines of being parallel will definitely give us what we need to get there. I think what I'm trying to get at is, my brain thinks, well, if ED and EB are congruent, then their arcs will be congruent. So using the parallel lines, can I prove that those triangles are congruent, or at least the bases of those triangles are congruent, right? Isn't that what I'm looking for? And then you start realizing what about radii? They're all the same, right? So if all those sides are congruent, then all I have to do is prove that those angles are congruent, right? And can I do that? Yes, I can. Knowing that property of parallelism, I can transfer that down. So that would be kind of the logic. Like I said, I just want to think these through. I really liked number 2 a lot, okay? It gave you a hint. It says you may use the tangent segments conjecture. That's on page 312, not 314, by the way. You might want to mark it right there. It says 314. It's actually on 312. Does anybody remember what the tangent segments conjecture is from so long ago? Anybody want to look it up on page 312 of your book and read it to everybody? Because you actually, if you have that, this makes it much easier for you. So, Maddie's looking it up there. Right? Yeah. 312. Tangent segments conjecture.
Tangent segments to a circle form a point
From a point?
from a point outside the circle. Is it congruent?
Are congruent to each other.
Congruent,
Yep.
okay.
Oh, that's right. The link is in your
Yeah,
book.
it's
Yes,
like
they
there.
are. So it's saying that if I have a point out here, right? And if I run a line that's tangent, right, from that point, and then I run another one that's tangent, these are going to be the same. That's what that says, right? Segments from the same point tangent to that circle. How can I use that to prove that AB bisects CD. I have a hint, it's actually pretty easy. It's not complicated at all. Anybody feel slightly confident enough to? Okay, how about daring enough? Maybe not confident, but daring enough to try.
Well, because all the segments are congruent to the tangents, they're all congruent to each other, so CD is congruent to BD, so AB bisects CD.
That's it. That's all there is to it. It's like one of those things, if you know that one little piece, yeah. So I just wrote point X is a point outside the circle from which tangents CX, YX, and DX are all come from. Since they're all congruent, AB must bisect CD. That's an example of a paragraph proof. It's just a prose statement of the logic, okay? And in some situations, doing a two column proof, you'd have to put a lot more steps. So this would be perfectly acceptable for that. 3 is a little bit different, and that one's, it's a lot of fun. So we'll see how, this one uses stuff that goes all the way back, I think, to chapter 2 or 3. See if anybody can follow the logic through with this one. It does tell you to add BE to your diagram, right? So I've got point A out here. We don't have any assumptions of congruency when A is going through here, right? And he's kind of given you a little bit of a hint by labeling this arc as Z, this arc is Y, right? And this angle is X. And we want to show that X is equal to 1/2 of whatever Z is minus Y. And his hint was to draw that segment in. And this is purely algebraic. But if I was to think, if I had amounts, what would I know? If I knew what Y was, what would I know? Alyssa, what would I know? What would I know? I don't know. If I knew what Y was, I would know that this was half of Y, right? Right? Okay? And what I'm telling, I just actually I have no answer keys for these. In fact, when I post the answer key, if you find mistakes, I worked through them very quickly. You may find some mistakes. But what I'm trying to say is that I saw the 1/2. I'm like thinking to myself, I'm looking for things that have a half with them. That's how this popped out to me. So, is there something else like that that I can do? These are a tough crowd today.
The Z.
Isn't this going to be 1/2 of Z? Right? And then going back to your chapter on triangles. If this is a triangle, what is that? half of z. Okay? Let's see if I can turn this around here. I'm having a hard time. But what do we know about that angle? Isn't that what this is? Isn't this that outside, that external angle? What do we know about that? Okay, I'm just gonna,
It's like 2/3.
It's-
Huh?
1/3.
doesn't this equal a plus b? Remember, didn't we find that out? Right? In fact, we tore off those little corners, we could make that angle fit right there, remember that? Because remember, all of these angles add up to 180, so this plus this is 180, therefore this has to be this plus this, right? Okay? How can I use that there? Can't I make an algebraic equation from that? This is algebra, by the way, Matt. This really is. Can't I say that 1/2 z is equal to x plus 1/2 y? Light bulbs are going on, right? Can I say that? That this is equal to this plus this? Okay. Can I get from here to here? Yeah, right? I can say that x is equal to 1/2 z minus 1/2 y. Isn't it the same as x is equal to 1/2 z minus y? If you don't understand that, make sure you do. So if I subtract 1/2 of a y from both sides, right? I get x equals 1/2 of z minus 1/2 of y. And then I can factor out that 1/2. That's how I get x is equal to 1/2 times z minus y. I'm looking at your faces. Maybe I shouldn't have tackled this the first day back. But sorry about that. The thing of it is this is a way of proving out something though that now you know how to find this. Okay? Is if we have segments that, these aren't tangents, right? These are originating. But if I have this, or I can find, so in other words, if I have the arcs, right? All I have to do is subtract the small arc from the big arc and take half. That's what that tells me. Okay? So I've done it algebraic. I'm going to skip over to something that hopefully this will be a little bit easier. Let's turn the plate. Believe it or not, things actually get easier. Let's look at number 4. Especially when your memory gets jogged enough. 4 is actually not very difficult at all. You're not asked to prove it, you're just asked to find it. And again, if you follow the hint and you draw that diameter, everything falls into place, just like your logic puzzles. Somebody have an answer?
Is it
Yes. sorry, yes, I was thinking 40, because this is 40.
Oh, yeah.
Because this, you're right, though, the answer is that has to be 50. This has to be 80, that has to be 40, what's left has to be 50, right? Why? Did you know that?
Because it's a right angle.
Because tangents are at right angles to the diameter. That's right. Okay? Alright. That wasn't so bad. Okay. How about the next one? My way of, again, where would you suggest maybe you might draw some lines to help you figure this one out? Yep. Actually, I don't think you need diameters. What do we know about that little kite thingy? Remember we've done the little kite type thing? So what I did is I did this and this. You'll see what that will. If you do the radii and you basically draw the kite, now what do you know? You know something right away.
Is it 80?
That's what I get. We'll make sure everybody knows how to get it. What do we know about angles C and E once you've drawn the radii in? They're 90 degrees each. So what do you know about angles A and O? They have to be 180 degrees. What do you know about angle O? Therefore, angle A is 80, okay? They're puzzles, right? I mean, realistically, some of these, it requires a number of steps, but they are puzzles. I think I'm gonna let you do number 6. But pay attention to the notes when it says refer to number 4, okay? Number 4, well, it's the same idea. You'll see. You can, okay, so I'm going to leave you to do that one on your own. I'm going to turn to the next page that you have. Okay. You know, before we jump in, no, I think I'll do these. I have something else I was going to work on, some word problems that involve pi, but we'll go to those in just a few minutes. Okay, this was something that we really didn't spend hardly any time on before you got a couple of these problems on the midterm. But, so it's one of those that logically it makes sense, but it helps to practice it a bit, right? Okay, so if you look at, it's basically learning to go that extra step from knowing the degrees of an arc to being able to convert that to a length when we now have enough information to figure out what the circumference is. So if you look at problem, what's the first one on there, right? It's asking for arc, it wants the arc length, not the degrees, the actual length of the arc, okay? And so the measure of this arc, if we are told that this is a right angle, what do we know? The arc will be, it will be 90 degrees, which tells us it's going to be 90 out of 360, or 1/4 of whatever the length, the distance around the circumference is, right? So if I know that the radius is 12, did I say centimeters? Yeah. We're dealing with length, so we need units. If the radius is 12 centimeters, what's the circumference?
pi.
24 pi. Circumference is 24 pi. I need 1/4 of that, divided by 4. So that, this chord here, the length of it is 6 pi, right? Okay? Some of you had a lot of trouble when you had to make that extension for some reason on the test. Not for some reason. We didn't practice it very much, and I recognize that. It was the timing of, it would have been nice to have had one more week before the midterm, but we didn't have it. Not even one. have you guys come back to it. So let's look at the second one there. So what have they've drawn an equilateral triangle in there, right? What's the circumference of the circle?
6 pi.
6 pi, thank you. And how much of the circle is that chord?
1/3.
So how much is the length of the chord?
2 pi.
2 pi centimeters, right? We'll keep our units there. Okay, some of the numbers are going to come out into whole integer answers. So the third one, you're going to end up with a fraction. And typically, keep it as a fraction or a decimal. But how would we figure out the third one? CD. Is that right? Yes, CD. Somebody walk me through this one. Noah, how would I figure that out?
Well, the measure of the arc would be 2 times 36, which is 72.
Right?
72 divided by 360
72 out of 360. It's a proportion, right?
is 1/5.
Hmm?
It's 1/5, right?
Yeah. Right?
So it'd
Exactly.
be 1/5 of 8.
Of a pi, right?
Of
Yep.
8 pi.
So you end up with 8/5 pi or
Yeah.
1.6 pi. Right, we're keeping our numbers in. You wouldn't convert them out of pi unless you're doing a word problem and you need the number that isn't pi, right? Okay. So I'm going to have you guys work on the next 3 for homework, okay? Let's look at the bottom. Just make sure you know how to do the reverse situation. Okay, here we're given the length and they want us to find the radius, okay? So I've been given a circle, right? And there's an inscribed angle, what, 30 degrees? Is that right? And it tells me that the length of the arc is 6 pi. How do I find out? How do I get the radius? Is that what they wanted? Any ideas? Well, how about I get the radius if I know what the circumference is, right? What the total circumference is, yes?
With the angle with 6 pi on it be 60.
And so it'd be 60 degrees, which is 1/6. So we're saying that 6 pi is 1/6 of the circumference. So what's the whole circumference?
36.
Therefore, and this is also the reason to keep answers in pi, what's the radius?
18.
Half of that, half of the 36. Okay? Do another one of those. Let's do number 2. Again, the key to these is to find what's the whole circumference. Then I take half of whatever's in front of pi and I've got the radius, right? Anybody know where to start? Yeah, that's where you start, by the way. Akita, I don't know if you got it. This one here? Oh, yeah, because that's 125. See, okay, you're doing it the other way around. But that's perfectly fine. He's going a different way I did. I used the cyclic idea that that's going to be 125, which meant that this whole thing is 250, which meant that this has to be 125. So how would I solve to get the circumference with this particular one? Guys, I think this is the hardest part for these working backwards. Take the words and put them into an equation. okay? 25 pi is some part of the whole circumference, right? Okay? And I know now what that sum part is, okay? Because that inscribed angle, okay, that cyclic quadrilateral, down at the bottom, it's 125 degrees, right? Which means that whole circle is 250, which means the 25 pi is 125 out of 360. Make sure you can follow that logic through. These are breadcrumbs, okay? Does everybody follow that logic through? Okay? Now it's just a matter of, if I want to get C by itself, multiply each side by the reciprocal, right? If I multiply this by the reciprocal, it goes away, right? It becomes 1 times C. Did that look like, Betty, you follow me when I did that? Okay. So when I do the math here, I end up with the circumference is equal to, somebody get it? I think it actually comes out to a nice round number if I'm not mistaken. What? Isn't it, if 25 over 125 is 1/5, well, we had an earlier problem. What's 1/5 of 360? You guys are super quiet today, and I'm having a hard time reading your faces, so I want to make sure, I'm not sure if I'm going too fast and you're getting it, or I know it's the day after the holidays, so I know I'm used to a quiet class, but I just want to make sure I'm not blowing through this too fast. I'm recording this too, so you could go back over it if you forget. Okay, but does everybody understand where that came from? If I do the math on my calculator, I can do 25 times 360 and divide by 125, but it's easier to start with the 1/5, right? Which I know is 72. So what's the radius?
It's just half of that.
Exactly. Half of what's in front of pi, 36. R is 36. And again, that's why you keep your answers in terms of pi, okay? So I'm going to let you do number 3 on your own. Okay? Okay. Go over to page 17. I liked this page. Was a really good page. Here, what I want you to do, there's no numbers to speak of. What you want to do is indicate algebraically what you know based on what they've drawn there. So for the first one, we know that B is going to be twice A. So we could have said A is half of B. We could have also said B is twice A, right? Okay, either one would have been correct. How about the second drawing right underneath that? What can I say based on that drawing?
A is 90 degrees.
A equals 90 degrees, right? That's what I know. How about the one after that? What do you think? I've been calling on you, Catherine.
Well,
The
A
second
plus B equals 180.
A plus B equals 180, exactly. Okay. And how about the third one over there? I'm going across. There's no numbers on these, sorry. What does that diagram tell you? Maddie, think you know?
A equals B.
We would say the measure of A equal B or A is congruent to B, either one. And you know what, if you wrote A equals B, I wouldn't care. It's just that little nitpicky, if we're talking about length geometrically, we'd say A is congruent to B. But we could also say if A is a number, then A and B are going to be equal, right? Okay, going down to the next row on the left, we have 2 chords that are marked congruent. What would that tell us, Olivia?
And the measures of A is what the measure B congruent to measures of B.
So we would say A measures are equal.
A is equal to B.
A is equal. A is just say A is equal to B. That's fine. Okay. And then what about the next one? Melissa?
They could be.
Same thing, right? Okay, if they're parallel, that means the distance between them is always the same. And it also means that they're and that the chords are equal. That's the key to a problem coming up. How about the little kite thingy there, Noah?
A plus B equals 180.
Yep, exactly. And then I have two little bow ties down at the bottom. Sylvia, what does that tell me?
A is equal to B.
Yeah, the measures are equal, the angles are congruent. Then how about the next one?
Is A half of B?
A is half of B. We actually proved that out. This is actually in one of the, in the book, I don't think you've even run across it in the book, but it's in one of the problems that we did. It's in one of the problems we did somewhere else. Oh, look at the top of page 12. What's the measure of arc CD? It's 100. What's the measure of angle BCD? 50. It's half. That will always be true, okay? And then finally, the last one there is the one we all did algebraically on the board. So what would angle AB equal to?
Isn't that the 1/2 CD thing?
Yeah, 1/2 big arc minus small arc, right? Basically, so A would equal 1/2 C minus B. So if you know these are the shortcuts. Actually, some of them you could solve without some of those more advanced ones, but then you have to draw in lots of extra lines, and basically you're reproving something you've already proved to yourself. Okay. I think I'm going to leave page 18 for homework. We're going to start getting back into the Pythagorean theorem and radicals here very shortly, but I'm going to save that for Thursday. And I've got one more other area that everybody had trouble with on the exam was word problems. Okay, so take one of these and pass them down.
I think we need one more.
You sure?
Yes.
Okay. Well, that's not good. I may have to print another. I might have to print another one. Is it? I am short one for sure. Okay, let me print another one because the only one I've left has the key on it. So it looks like I printed an extra one of those. I'll be right back. 6 exercises. Why don't you take a look at the first one? What is that? I'll put in the number to print, but sometimes they don't all come out. So, who's missing? Sorry. Okay, these are the kinds of problems that definitely people were having some trouble with. And you know, I'm good at these, but I still draw a diagram. I start every single one of my problems with a diagram, okay? So here, the first one that they have here is, you've got the Earth, right? And then you have this satellite that's orbiting around the Earth, right? Okay? And what does it tell us? It tells us the radius of the Earth, if I'm not mistaken. Is that correct? And it says the radius is about 6,400 kilometers? Okay. What else does it tell us?
From the Earth to the satellite is 2,000
So
kilometers.
there's 2,000 kilometers here. So when I look at what they're asking for speed. Speed. Basically, I've talked about dirt, right? Speed is a rate. So my rate is my distance over my time. So when we say miles per hour, we only have one number because we're dividing by 1 hour. But this is, we're having a distance, some distance, we're trying to find that distance, right? So we need to know how far the satellite is rotating. Well, isn't that the circumference of a circle? So when the satellite rotates all the way around, how far does it go? I get 8,400